Example number it is 2.4. It is for class 12 physics. Okay, it's a very important problem. First we'll see what is the question they asked. Okay, there are four charges they placed in the corner of the rectangle, square. Okay, it's given in the question. Okay, they placed minus q, plus q, minus q, plus q, a b c d. It's a four corner they placed as the four charges. Okay, the first question, find the work required to arrange this system. Okay, find the work required to arrange the system. The second question, a charge q naught is brought at the point of center. Okay, now what is the work done, extra work done is required to place the this charge at center. That's the question. Okay, first we'll see what is the energy formula. Energy is equal to force into displacement. Simply we can take it like this. So energy U we can take it 1 divided by 4 pi epsilon naught q1 q2 divided by r square into r get cancelled. Okay, so electrostatic potential energy 1 divided by 4 pi epsilon naught q1 q2 divided by r. According to this, r is going to be the distance d. This is the energy formula. Okay, to place like a rectangle, how much energy is required? That's a question. Okay, so to place this two charge, energy 1, to place this two charge, energy 2, to place this two charge, energy 3, and this two charge, energy 4. Like that we can take it 4 part of the charge. It's not only depend on the 4, the diagonal side is going to be u5, and this diagonal side I am going to take it as a u6. There are 6 energies required to arrange this kind of system. Okay, so total energy is going to be, directly I am doing the problem. Okay, if you understand the logic easily, you can do this kind of problem when what they are asking in a board exam. Okay, total energy is required u1, u2, u3, u4, u5 and u6. Okay, these are the energies required. Okay, now we'll see what is u1. Okay, u1 I am taken the energy between minus q and plus q. The distance is going to be d. Okay, so we know the energy formula. First u1 we have taken the it is going to be d, and it's going to be c, it's going to be minus q, and it's going to be plus q. We'll see the answer. 1 divided by 4 pi epsilon naught, you can take this value as a k also. q1 is minus q, q2 is plus q, divided by distance between these two is going to be d. Okay, the energy 1, it's going to be u1 is going to be 1 divided by 4 pi epsilon naught, 1 divided by 4 pi epsilon naught, it's a constant, and minus q square, q square divided by d. Okay, now we'll see what is u2. U2 we can take it this side. Okay, c to b, this one we can take it c to b. Okay, so one is plus, another one is minus. It will be like this, minus q and plus q. The distance is going to be d distance. Distance is going to be d distance. Same 1 divided by 4 pi epsilon naught, it's going to be minus q into q. The distance is going to be d. Okay, it's not d square, d. Energy value we won't get as a d square. u2 is going to be 1 divided by 4 pi epsilon naught, it's minus q square divided by d. Now u3, what is u3? Okay, so we are u3 is going to be the charge between it is a and b. It's going to be minus q, and this going to be plus q. Okay, distance will be d. Same 1 divided by 4 pi epsilon naught, q square divided by d, because same combination only we are getting ab, bc, cd and da. Okay, so u4 is for da. It's going to be same 1 divided by 4 pi epsilon naught, and it's going to be q square divided by d. The reason it's going to be like this, this is minus and this is plus, so q minus q and distance will be d. Okay, so why we have to take it energy q as a negative, force no need to take it as negative, but u, energy is a scalar quantity. Scalar quantity you should take it this negative symbol. Okay, vector quantity no need to take it as a negative symbol, because vector quantity is going to represent as a direction. Now I got u1, u2, u3, u4, everything will be equal. Okay, so sides it's going to offer with the same potential energy. So u1, u2, u3, u4 will be same. So we wrote already equation like this. Okay, so this 1 2 3 4 5, it's going to be 4 times. Okay, sorry, 1 2 3 4 times of u. Okay, it's same value, everything will be same. Now we will see 5 and 6 which is offered in a diagonal side. Okay, so diagonal side, what's going to happen, we just will see we have like this diagonal and we have like this diagonal AB and CD. Okay, like this diagonal. Okay, first we will see diagonal length. This is D and this is D, the corner, it is D and this is D. Now what is diagonal side? I am using Pythagoras theorem, d square plus d square whole square. D square will write 2 times of d square whole square will get as a root d. Okay, so diagonal side we got from the question. See here, diagonal length I can get as a root 2 times of d, root 2 times of d. This diagonal also I can get as a root 2 times of d. Okay, because I used as a Pythagoras theorem. Okay, root 2 times of 2d square will get, that's going to be root 2 times of d will get. Okay, diagonal length I got. Now I am going to find what is a u5 and u6. Okay, see here how I am going to find u5 and u6. See, u5 a is going to be plus and this side is going to be minus. Okay, and this is minus, sorry, this is plus, this is plus minus, here plus, here minus. That's what's given in a question. Okay, now u5 the distance is going to be root 2 times of d. u5 is equal to 1 divided by 4 pi epsilon naught, it's minus q into minus q divided by root 2 times of d. Minus minus is going to be plus, so u5 is going to be 1 divided by 4 pi epsilon naught d square root 2 times of d. Okay, you here it is energy is a vector quantity, definitely you should take it as a negative sign as a charge. Okay, sorry, scalar quantity. Because of scalar quantity we are taken negative. Vector quantity means no need to take it as negative because direction will be there. Okay, now I found the d2b u5. Okay, again this side diagonal I am going to find u6, the distance is going to be root 2 times of d. Again we have u6 is going to be it's going to be 1 divided by 4 pi epsilon naught, it is plus q into plus q because both the charges is plus q, it's going to be root 2 times of d. Again the distance will be the same, so u6 also will get u6 energy in sixth place. u6 is going to be 1 divided by 4 pi epsilon naught q square divided by root 2 times of d. Finally we got u5 is equal to u6, this two will be equal. Okay, in a single rectangle, okay, there are 5 energies will be there. It's going to be u1, u2, u3, u4, all will be equal. The diagonal side, it's going to be u5 and u6, this two will be equal. Okay, and now we'll be writing the equation. Total energy is going to be u1 plus u2 plus u3 plus u4 plus u5 plus u6. Okay, this two will be equal and this 4 will be equal. This is 4 times of this u. Okay, and this is 2 times of this u. Okay, the diagonal side, it's going to be diagonal, it's going to be side of the rectangle. Okay, now we are going to see what is sides. Already we have the solution, it's 4 times of minus 1 divided by 4 pi epsilon naught q square divided by d. Okay, this we will get plus only because we know the equation already, 1 divided by 4 pi epsilon naught q square divided by root 2 times of d. That's it. Okay, we can take it as a common outside. We solved this. Okay, so it's going to be common, so this will be 4 times with the minus, this will be 2 times with the plus. Okay, like that we have. So I am taken minus 1 divided by 4 pi epsilon naught q square divided by d. I am taken common. Okay, q square divided by d. So that means 4 will be there here. 4 minus I am taken common. Here plus is there, no? The sign will be changing with minus. Okay, and 2 by root 2 will be there. Okay, this is the final equation we are going to get. So u is equal to minus 1 divided by 4 pi epsilon naught q square divided by d. It's going to be 4 minus, see here, 2 we can write as a root 2 into root 2, root 2 into root 2 divided by root 2, root 2 get cancelled. So we'll get 4 minus root 2. The answer is going to be, u is going to be minus 1 divided by 4 pi epsilon naught, which is going to be called as a k, q square divided by d, the bracket 4 minus root 2. This what we have the final energy. Okay, it is a solution for the question 1. Further you can proceed. Root 2 value 1.4. okay, so 4 minus 1.4, finally we'll get 3.6 times of this value. Like that also you can do. Okay, see the question, the first part of the question we completed. Okay, the first part, what is the energy is required to store this kind of system. The energy is required to store this is going to be minus q square divided by 4 pi epsilon naught d 4 minus root 2, like this. Okay, now second one, B question, the charge q naught is bringing at the center. Okay, what is the energy is required? See, this plus and it may be plus, will take it. Okay, so how much energy is required? No, in case first we'll see how much is going to be created. It's going to be ripple with this. Yeah, electric field will be like this, and this going to be plus and minus is going to be attract this side, it's going to be attract this side, and this plus is going to repel this side. Okay, I'll repeat again. Actually the answer will be 0 for B case. Okay, the reason why it is 0, the net electric field is going to be, net electric field or force at that particular point will be 0. Okay, so it's going to be minus plus minus plus. Okay, the center only we are learning what is the energy is required. Okay, actually 0 answer. How? No, plus, in case imagine this is plus. Okay, it's a source test charge, you can take it plus or minus whatever you want. E1 is created outside, because of this plus E2 will be created this side. Okay, because of this minus is going to attract E3 will be this side, because of this minus it's going to attract this side, it's going to be E4. Okay, so the net value of this is going to be 0, net value of this going to be 0. Even you are taken force also, net value is going to become as 0 at the center. Okay, 0 at the center. So that means we are not required any extra energy to bring this charge at center. Okay, thank you for watching my video. If you like my channel, please subscribe. Thank you everyone.